All right, so here we're going to do lead emissions historic. So the table gives the total emissions of lead into the atmosphere for selected years. And what we need to do is find a logistic model for the data, estimate the location of the inflection point, and then indicate where the curve is concave up and where it is concave down. So if we're going to do this, when we do the logistic model, remember, we usually align the data. So I would say that's 0, then 5, 10, 15, 20, 25, and then we can use our numbers that are given directly here. So if we go to our calculator, I've already typed it in, and so this is what our data looks like in the calculator as far as the stat plot. So it kind of looks like it's coming down, and then it's kind of going back that way. So it's concave down here, concave up at this side. So it's a decreasing function. And so now we need to find the stat plot. So let's go, and we need to get the logistics. So that's B. L1 is there, L2, we want to put it into Y1, so we're going to go vars, Y vars, 1, 1, then enter, and this one's really quick, so we get this. Now, if we go over here, that's going to be our equation right here. So, one of our horizontal asymptotes is going to be 251.3 if we go to one decimal place. Another one would be 0 in this case. And now the other thing it asks for, not only this, but it also asks for where that inflection point is. So looking at our graph here, things aren't labeled. It's hard to determine, but we know it's going to be somewhere, I would say about here, which, I'm not sure what that is. I think it's 5, 10. So between 5 and 10, maybe, somewhere in there. But there's a nice feature. And again, like I said, this is something we'll learn about in the future in this class's derivatives. And we can take the derivative of this function a given, and it will tell us the minimum value in this case, probably, of where it's at. And then that will be where our inflection point actually hits. So what we need to do is we need to type the derivative. So we have to go to math, and then we want number 8, the end derivative. So we'll hit 8. And we want to d over dx, and then we want to of y1. So then we have to type y1 in there, and the way we do that was just kind of like if we put it all in there, and x equals, in this case, x. And so this is how we're going to find that inflection point without guessing, and this will give us pretty accurate value as far as where it's at. And so now what we can do is we can go and look at our graph. And so the derivative is giving us this graph here where it has this dip, which means it's going to have a minimum function. So we need to find out where that dip is, because that's going to be where the point of inflection is. And again, we'll learn about y and all that stuff later, but now we're just going to actually just kind of use it. So we need number 3. And so we'll go down to the red curve, our left bound, about maybe there, our right bound, let's call it there. If we want to guess, we can say guess that. And it says the minimum is at 6.948. And so that means up here at 6.948, that's going to be our inflection point. So that's what I'm going to use. And since we can't guesstimate that well, I'm just going to round that to approximately 7, because that's going to be as best as we could do. And if we think about that, that's about right there. And if we went by 1, 2, 3, 4, 5, that would make sense that it's around 7. So let's go back to here, and now we have to write down everything that we just did. So first things first, the logistic model. Okay, well, we were doing lead, and so I guess we could do, I don't know, L of T, how much lead at time year T. That's going to be, and again, these probably we should use approximately equals to, because we're not exactly equal, we're rounding. And so that was 251.299 over, then it was 1 plus 0.138 E. And it was negative because it was decreasing, but negative is positive, so that's going to be 0.285 T. And this is going to be million tons of lead emissions at time t years after 1970. So t is going to be, less than or equal to, what was it, 25, and greater than or equal to 0. The location of the inflection point, well, again, we estimated that to be a t is approximately 7. It was, 6.948 or something like that. But we're going to just say it's approximately 7. And so at t of 7 years past that, that gives us about 1977 is when that inflection point is. Now, indicate where the curve is concave up and where it's concave down. So remember, it's a decreasing. So we have that. And that inflection point's where it changes. So it's concave down. So C, concave down, is going to be basically our t less than 7. And then concave up is going to be t greater than that 7. Okay, or less than 1977 or greater than 1977 if we want to look at it as a year, or if we want to look at it as just after t after 1970. Okay, and so that's how I would do that one. And again, we used that derivative to find this exactly or as close as possible, and then we could round it to 7. But that's the best way to do it. And again, we'll find out about that in a later chapter. All right, so we'll stop there and we'll come back with another one.